Welcome to the second problem-based tutorial. Problem statement. Simulate a half-wave diode rectifier and perform the following tasks. 1. Use voltage measurement and current measurement blocks to measure the circuit voltage and current respectively. 2. Display the voltage and current waveforms on separate scopes as well as on a single scope using a multiplexer. 3. Use cursor measurement to determine the frequency of the output voltage. Or, use cursor measurement to find the maximum, minimum, root mean square, mean, and peak-to-peak values of both the voltage and current waveforms. So, let's get started. Create a new model. Launch Simulink and start with a blank model. Click on Save and give your file a suitable name. Add blocks into the model. Launch the library browser to add the required blocks. To add a diode block, click on Simscape, then Electrical, then Specialized Power Systems, and then click on Power Electronics. Now, right-click on the diode block and add it to your model. Click on Passives and add a series RLC branch into your model. We will also need an alternating current voltage source. So, go to Sources and add the AC voltage source block into your model. From commonly used blocks, add a few scopes and a multiplexer block into your model. Arrange and connect. Also add voltage and current measurement blocks from the Simscape library. Connect the current measurement block in series through the circuit and the voltage measurement block across the load. Connect the scopes to observe the waveforms. Also, connect the inputs of the multiplexer block to the outputs of the current measurement and voltage measurement blocks. You can change the number of input ports of the multiplexer when required. Double-click the alternating current voltage source block and set the peak voltage to 311 volts and the frequency to 50 Hz. 311 volts is the peak value for 220 volts RMS. Double-click the series RLC branch block, replace RLC with only R, and set its value to 10 ohms. As the frequency is 50 Hz, the time period will be 0.02 seconds. So, if you want to display 2 cycles on the scope, set the simulation time to 0.04 seconds. Run the simulation. Click on Run to start the simulation. Uh-oh, we received an error. That is because we forgot to add the power GUI block to our model. The power GUI block is required for simulating any model that includes Simscape specialized power system blocks. To add the power GUI block, type power GUI in the search bar of the library browser and press Enter. Now add it to the model. Make the necessary settings and click OK. Click on Run again to simulate the model. Visualize the results. Double-click the scope to open it. Let us differentiate between the waveforms. Go to Style Settings and check which color represents which signal. The yellow waveform represents the current through the circuit. The blue waveform represents the voltage across the load. Measure the voltage waveform frequency. Let us now see the voltage waveform separately to take measurements from it. Click on Cursor Measurements. Place one cursor at the start of the waveform cycle and the other at the end. Zoom in on one full cycle of the waveform. Now let us measure the frequency of the output voltage. 1 divided by delta t gives the frequency of the waveform, which is close to 50 Hz. As you can see, one cursor is placed at time t equals 0 seconds, and the other cursor is placed at time t equals 0.02 seconds, which matches the time period of the voltage waveform. This confirms that we have placed the cursors correctly, and the time difference is 0.02 seconds. Measure signal statistics. To make further measurements, go to Signal Statistics. This will show us different parameters for the voltage waveform that are maximum or peak voltage, minimum voltage, peak-to-peak voltage, main voltage, root mean square or RMS voltage. Now let us repeat the same measurements for the current waveform. The frequency again is close to 50 Hz. Let us now open the signal statistics for the current waveform. Here, we can see the same parameters as before: maximum current, minimum current, peak-to-peak current, mean current, root mean square current. Summary of today's lesson. In today's lesson, we completed the following tasks. We used voltage and current measurement blocks to measure the circuit voltage and current respectively. We displayed the voltage and current waveforms on separate scopes as well as on a single scope using a multiplexer. We used cursor measurement to determine the frequency of the output voltage. We used cursor measurement to measure the maximum, minimum, root mean square, mean, and peak-to-peak values of both the voltage and current waveforms.